Just all right. Let's go. Going live, and we are live. Hello, everyone, and welcome to the Gravity Max live stream. Today, we have a fun topic. It's a set of objects in space that I am very much fond of, and we're going to talk about them. So I'm here with Sebastian, my co-host.
Hello, everyone. I'm doing really good. How are you doing, Max?
I am doing pretty well also. It is, I have a 3-day weekend, so I'm
Very
happy
nice.
and, well, I would say I'm more relaxed than usual, which just means like normal, I guess, because it is a hectic time, junior year. You're probably second semester, junior year, I feel like is just the worst.
Yep.
I don't know.
Absolute worst.
Absolute worst.
Today is Valentine's Day, and
Yes.
to commemorate that, we are having the Gravity Max live stream. Nothing else.
Yeah, exactly.
But yeah, we got a really good topic today. We're talking about the Kuiper Belt, the Oort Cloud. But let's do some plugs. And you know what? In the chat, tell us who your Valentine is.
Yeah, tell us. That's a very nice idea. All right, so to begin, visit the Gravity Max website at gravitymaxmedia.com. I just updated it recently, actually. So there's I added a new page just about all the different YouTube channels that are sort of related to Gravity Max Media, which includes, Govern Max, which is that government channel. I'm probably going to make a video for that like tomorrow because some new documents have occurred on like Thursday. There's a new one. I don't know how I'm going to, because there's not really a document I'm going to look that comes with the like acquittal, like the impeachment thing. Like there's not really a thing to read unless there is. So I'm going to look into that. But so stuff that's just constantly updating that channel. There's always more stuff for that channel. But then also follow Gravity Max on Instagram, Twitter, Facebook, and Patreon to get updates about what we're doing. Like last week, we had to start an hour early. So just make sure to look out for that. So follow those accounts. So then follow Sebastian on social media, Instagram and YouTube, 128 seconds. Links in the description. 128 seconds is Sebastian's channel. And he makes great short educational videos that are like the sort of counterbalance to these long form like podcast discussions. If you want a quick like informational like video, go to 128 seconds.
And I think I'm going to be changing my, just announcing it here, I'm going to be changing my upload schedule to, I think it's going to be twice a month.
Okay.
So every other week is basically how it's going to be.
Yeah, junior year again getting to you, right?
Yeah, it is.
Yeah, it's unfortunate. Like, I've been trying to do, like, roughly one video a month here for Gravity Max, just, like, at some time in the month. But it's getting difficult.
Yeah.
Even just that. It's, like, so much stuff. I am so tired. But let's continue. A Waddle to Point. Link in the description. It is my second book. It is the sequel to the first one. It is a science fiction novel. It takes place in 2131, so it's a fun book. I would highly recommend, so links in the description. And with that being said, the Untouchables.
The Untouchables.
That is today's episode.
May not know about the Kuiper Belt and the Oort Cloud. In fact, you probably don't know about the Kuiper Belt and the Oort Cloud. This is why they're called the Untouchables. You don't know about them. We're here to teach you about them because they are in your neighborhood and you might not have known about them. They're that one house on the corner that you really do think someone lives there, but you can't be sure. And are you ever going to knock on their door and invite them to the block party? Hell no. These are the Untouchables.
Exactly, yeah. So the Kuiper Belt and the Oort Cloud is this sort of collection of icy objects out in the dark outer reaches of the solar system. and they don't get a lot of attention. People don't talk about them that much. So we thought that that was an injustice that had to be corrected. Because, yeah. So we're going to talk about them, and they're fun. So I guess let's just begin. The Kuiper Belt. So the Kuiper Belt is a toroidal-shaped object, or not object, but area of space that spans from roughly 30 astronomical units to 55 astronomical units away from the sun. So you may remember that the orbit of Neptune is 30 astronomical units away from the sun, so it's basically right around there. It's just outside the orbit of Neptune is where all these objects reside. And so the Kuiper Belt is similar to the asteroid belt. However, it is much larger and much more massive. So there's a lot more stuff here, and its composition is different. The Kuiper Belt is much more composed of ice, and in astronomy, ice doesn't just mean like frozen water. It can be ammonia, it can be methane, a ton of other substances that aren't very carbon dioxide, a ton of other substances that aren't really nice, that you don't really want to put in your ice cold lemonade. But
Yes.
it's still, they are there. So that's what these, and then of course there are rocky materials as well. But yeah, so let's begin with the most well-known Kuiper Belt object, Pluto. So look at Pluto right here. This is on the left. This is the New Horizons image that was just recently, 2015. But
That's very high res.
That is a very high resolution image of Pluto. You should see the other side of Pluto because New Horizons was just a flyby, so it just it was only able to get one side, right?
Mm-hmm.
So the other side, if you were to look up like Pluto globe, the other side is completely pixelated. So
yeah, it's such a cool looking.
Get the heart shape, you know.
Yeah, I know. It's such a cool looking object. It's got the heart. It's got the red area, and it's got a nice color palette. It's very underappreciated in terms of looks. I think people know it for one thing, and that's that it's small. The size of an object does not determine its worth.
Yeah, I definitely agree with that sentiment because Pluto, I would say, is the largest double planet system in the solar system if you are not counting the Earth, the Earth and the Moon, which it would be the next sort of with the size ratio. You could count it arguably, but I do not count it. And there's a very specific reason why. So this animation right here is of Pluto and its moon. And if you look, you notice that they are tidally locked. Both of them are tidally locked to each other. So the moon in the sky always looks the same, and that's because the same side of the moon is always facing Earth because it is tidally locked. But the Earth rotates independently of the moon's orbit, so the moon will rise and set. But on Pluto, Pluto is tidally locked to its moon as well as its moon is tidally locked to it. Its moon is called, I don't know, Charon or something. There's like 20 ways to pronounce it. So we're just going with Charon, I guess. So, yeah. And it's just very interesting because if you look at this system, you could almost imagine, like if this were a tiny scale model, you could almost imagine just tying a string between those two objects, and that string would stay perfectly taut as it sort of rotated. It wouldn't get wound up, it would stay in the same place on the surface because if you are on any given location on Pluto and Charon is in the sky, it will remain in exactly that part of the sky forever. And if you are on Charon looking up at Pluto, the same holds true. And so what's very interesting about that is that it allows for the creation of a space elevator that begins with a base on the ground on Pluto, climbs up into space, and then back down onto the surface of Charon. And the top of the space elevator is on the surface of Charon, which is just very fascinating. That's why I very much like Pluto. It is not a planet. Just going to put that out there. People are still sort of salty about that. but it is not a planet. Okay, just let's get that out of the way. It is a dwarf planet, but I argue that it does not have to be a planet to be very cool. Because look at that. You could like build a space elevator from the surface of Pluto to the surface of Charon. Like literally a tower that is so tall that it reaches the moon, and that, if you had strong enough materials, would actually work. And the surface gravity on Pluto is something like 8% that on Earth, so you very much could do that, I think, with modern materials. Mm-hmm. So this is like a feasible thing we could do right now if we had the money, of course, and the resources, but it's not a technology problem, I guess, is what I'm saying. It's just a like brute strength problem. So there is no new technology necessary to build a space elevator like what I just described on Pluto. It's just sort of, obviously, it is very far away, 30 astronomical units, and we can only just barely get things to it. It takes a long time to get there. But yeah. So that's just very interesting because hypothetically, in this situation, there could be a staircase. I mean, not really, because this would be, thousands of miles, but you could literally walk from the surface of Pluto up a flight of stairs and then onto its moon. Like, there is no structural problem. It's just so fascinating, just the continuous nature of this world. So that's why Pluto, I think, deserves high accolades. It deserves all the accolades, not because it's a planet, not because it's just the first discovered Kuiper Belt object, specifically for this reason, that it is very, very amazing. Like, I think it's very just cool, I guess. That's the only word I can think of, is cool, because it's just an interesting thing. You know what I mean? Yeah. I mean, it would be like a tourist attraction. I would visit Pluto just for the sake of going up and down the Pluto space elevator. It would be like it would be like what is it called? Like the Camino in like France and Spain, where you go to like the church or whatever. Mm-hmm. You know what I'm talking about?
Yeah, I think I've heard. I think my mom might have gone there. But yeah, stuff like this, and that's always going to be the coolest thing. Is just to see the architecture on other other objects, other stuff like that. Because. And we were talking about this largely in the holidays section of last stream, but there's going to be different cultures eventually, just because of how far removed things are. You're going to have people hopefully develop their own accents. I want to hear what a Plutonian accent would sound like.
Plutonian accent. Yeah, I wonder. It's just I really wonder how these. I agree with you too. I guess it's just because I'm not that much into linguistics, but I just have no idea what space accents would sound like. Yeah. Like, my only slight guess is that it would just sound like an international accent because, like, it's multiple different nations coming together. But that is I just have no idea.
Yeah.
Like, whereas other things, I mean, I like to think I'm good at predicting other things, but just with sci-fi, because that's just sort of what I do as a sci-fi writer, but not linguistics. I just have no clue. But
we should get a linguist on. Be like, what would space accents sound like?
We should do a linguistics episode with a linguist.
Ooh.
Any linguists watching right now, feel free to contact us. The email is gravitymexcontact@gmail.com. That's the business email. Oh, so we have some chat too. So Barry Rudin said something and then deleted it and then said another thing. So she says, I never heard of Find Kuiper Belt. You guys already taught me.
Yeah, it's really not a lot of people know about the Kuiper Belt because it's very niche. But what's hysterical is that it's very niche and incredibly large, and within the bounds of our solar system. So it is.
Yeah.
It's massive, and we have no idea about it. And that's always the funniest thing to me. But there's also just a lot of cool stuff in there. And a lot of people don't even realize that Pluto is part of the Kuiper Belt.
Yeah, exactly. What I find fascinating is that everyone, for the most part, knows of the asteroid belt, but no one knows of the Kuiper Belt. Like, I don't understand. I mean, I don't understand why the asteroid belt would be better known than the Kuiper Belt. You know what I mean?
Yeah, I guess because it's closer? Question mark. But
Yeah, that's the only thing I can guess.
yeah, I don't know. But you know what? We're gonna change that. People after this episode are not even gonna think about the asteroid belt. It's gonna be all about the
Yeah,
Kuiper Belt and the Oort Cloud.
yeah, exactly. Yeah, so the estimate they say that the Kuiper Belt could be 20 to 200 times as massive as the asteroid belt. And the asteroid belt, I think its mass is like a third the mass of the moon or something. Let me check that. Mass of asteroid belt. So, but the point is that there's a lot of stuff within the Kuiper Belt, which is just very cool. So total mass is just, it's 3% the mass of the moon is the asteroid belt, which means that the Kuiper Belt is 60% to 600% the mass of the moon. So you've got about, it depends. It could be less than, but it could be a few moons worth of mass within this system. And surprisingly, Pluto is very much less massive than the moon. So it's not like Pluto takes up all of that. But yeah, so this is just an interesting object. Like, something interesting about Pluto is that because of the eccentricity of its orbit, when it gets closer to the sun, its atmosphere, so when it's farther from the sun, the atmosphere freezes onto its surface and falls as snow. And then when it gets closer to the sun, it steams off again. And it has a very thin atmosphere, so it's not that catastrophic of an event, but it's just very interesting. Can you imagine that the atmosphere just literally snowing down? Like, it's just so.
That would be
Yeah.
very strange, to say
Yeah,
the
exactly.
least.
Because it's just so cold out here. But yeah, so if we go to composition, let's see. So the composition of Pluto specifically differs based on the color, as you mentioned, Sebastian.
Mm-hmm.
But yeah, it's just ice and rock mostly. And again, different types of ices here. And so so it's interesting because it's not likely that it will be a big exporter of materials just because it's out there. It's on the frontier. It's just too far away to be convenient, I guess. There are much closer sources of ice. This is what we were talking about even for the farther gas giants, is that there's just no need to export materials, But when it comes to interstellar travel, the story kind of changes because it is no longer at the edge. It's in the middle. But again, the Kuiper Belt, it only has, about the mass of the moon. It's on lunar scale. And so compared to Neptune, which is also right next to the Kuiper Belt, it's sort of why use those resources, Because if you want hydrogen, oxygen, any gas, you can essentially just get it from Neptune instead of the Kuiper Belt. But yeah. So that means that the main point of these objects is just going to be sort of local settlement. That's largely what the frontier was, again, in the American West. We come back to that analogy a lot, but I just think that's sort of what space is. There were some mining operations in Montana and Idaho, the Rocky Mountains during frontier times. But there was also a lot of just homesteading in Kansas, Nebraska, those areas that are just sort of fields, just flat, where people would just set up a home. And there really aren't many natural resources there that people were trying to export back east, whereas in the mountains there were. So Pluto and the Kuiper Belt, all these objects out here, I feel like they are more akin to Kansas, and the Great Plains areas than the mountainous areas, which would be more like Jupiter.
Just interesting fact. The sunlight on Pluto has the same intensity as moonlight on Earth. So the sun in Pluto's sky has the same intensity as like the moon in our sky on like whatever night.
Interesting. Where did you read that? I got that it was a little.
It's just facts, man. It's just facts.
It's just facts.
I don't. The planets.
Well, no, it's actually. Well, I did my own calculations. I don't know, maybe I'm wrong, but so Pluto is 30 times the distance of Earth from the sun, which means that the sun will be 1/900th as bright.
Mm-hmm.
So we can approximate that as 1/1000th as bright, and that corresponds to a change in apparent magnitude of 7.5. And so the sun from Earth has an apparent magnitude of negative 26.7. So on Pluto, the magnitude of the sun would be about negative 19.2.
Mm-hmm.
And so the magnitude of the full moon is negative 12. So
yes,
it's still a bit brighter, but
still
it's like the star Sirius compared to some of the dimmest stars in the sky.
Yeah.
I guess it's a similar step up. But yeah, it's very interesting actually in terms of brightness and what that means, because you might think on like Jupiter that like 4% as bright would be so dim and you wouldn't be able to see anything, but it's really weird how the human eye works. Like it's like a logarithmic scale or something, because just common indoor lighting is about as strong as sort of the sun would be on Jupiter, just ambient. Like it's really weird the way lighting is. Even the apparent magnitude scale doesn't even really encompass it. Like what does negative 19.2 mean? Like I can tell you what it means in terms of like how many watts, like 1.5 watts per square meter of energy from light, but again, that also doesn't mean anything. It's just sort of hard to capture an experience, I guess, in numbers, but we try, right? Yeah. So another thing that means, though, is that solar panels are not going to be particularly effective out here. So around the Earth, the amount of wattage you get from just 1 square meter is 1,367 watts per square meter. Around Pluto, it would be 1.4, 1.5 watts per square meter. So you cannot use solar panels out here. They would just not be effective. That would require it would require 100-ish, maybe like 60 square meters to power an average incandescent light bulb, a 100-watt bulb. So you would need probably like at least a square kilometer to power a small house, and that's a small house on Earth, where like air conditioning just means like, oh, it's 90 degrees outside and I want it to be 70 degrees. Whereas here on Pluto, your climate control is going to be, it is, negative 300 degrees outside, I want it to be 70 degrees. So solar panels would not be very effective out here. However, since Pluto, again, is mostly made out of ices, it means that there is an abundant amount of hydrogen, because whether it be water ice, nitrogen, like, ammonia ice, methane ice, all of those substances contain hydrogen. And water, at least, you can use electrolysis to remove the hydrogens. I imagine you can do the same for ammonia and methane. There's some way to remove the hydrogens. I'm just not sure if it's electrolysis. Mm-hmm. But you remove the hydrogens, and if at this point humanity has the ability to do nuclear fusion, then you could use the hydrogen for nuclear fusion. If not, it would be pretty difficult, but I imagine you can do power satellites. That's one thing that I talk about a lot, is basically if you just set up like thousands, tens of thousands of power stations very close to the sun that are just sucking in all this solar energy, like very close and very hot, then they can create a tight beam laser and direct it at some object out in space. And then that object can have a receiver, and that receiver can, pick up the energy. However, again, Pluto is very far away from the sun, so that would begin to get difficult. So I would say this range of the solar system, this area, is where if you don't have nuclear fusion as a viable technology, it begins to get difficult to colonize this area. Like, it begins to present a problem if you don't have nuclear fusion, I would say. And I wouldn't say that would be a 100% like a problem that you cannot solve, because people live in Barrow, Alaska, and like Svalbard. Not very many people, but they do. And those places they get zero sunlight for many months at a time. So
yeah,
Pluto's like the Svalbard of the solar system.
Yeah, we need to do a tier list of all the objects in the solar system, and I think Pluto would be somewhere near the top, because it's cool. It really is. And again, that Plutonian accent.
Just gotta.
I want. Yes. I feel like, and tell me if you get this vibe. I feel like the Plutonian accent would be very over the top and very educated, because on Pluto, I feel like they'd be doing a lot of technical work, because they would be the main jumping off point to the rest of the Kuiper Belt and to the Oort Cloud, right? If not around Neptune. So they'd be doing a lot of technical work, gathering a lot of data on the ice on their own planet, or on their own heavenly body, and the ice throughout the Kuiper Belt. I feel like it would be very educated, and it would be all of that. And I think that would be very cool.
It would be posh?
Yeah, kind of posh. Yeah, you know what? That's probably the best way to put it. Just very posh, kind of British, kind of not, you know?
Yeah, I could see that. Yeah, it's interesting. Again, it might not even be like an accent of English as we think of it, because I imagine space will sort of... Well, right now, English is the official language of space, essentially. Like, that is what all the communications in space is done with. Although I'm pretty sure the astronauts have to learn Russian as well, for the sake of, like, cohesion, I guess. I don't know. But I don't know. I don't know what the language of space will eventually become. It's very interesting to think about. There could be rivaling... I like to think that eventually there's going to be some sort of like merger, like some new sort of space talk. I don't know.
Space talk? You think they're going to have space slang?
Yeah, I think they're going to have like, well, because you're going to need new words for space, for one thing. And then you're also going to have to reconcile a ton of different languages together.
We got to go back. We got to go back to the, which one was it? Was it on Next Steps? Or I guess that's not what it's free real estate, because that's what the audience does it as. Yes, it was, with the Neo Angeles girl and the Palace Prime boy, with the Mite Bites and the Glasslands and the Rig and the Beetlejuice drink, VR parties. And of course, the Palace Prime boy claims to have personally met XSJ12.
I like to imagine that sometime in the next 300 years, there's going to be like a Neo-Indo-European. Because are you familiar with Proto-Indo-European?
Proto-Indo? I don't think so.
It's basically just this hypothetical language that linguists talk about that like existed thousands of years ago, and that all of the languages of India and Europe have developed based on that. I imagine, I guess, then, like, the Middle East as well. Like, all of these different languages.
So that would be, like, the first language, basically, right?
I guess, but I'm not sure, because then you would also have, like, the Asian languages, like, East Asian languages would... I'm not sure if they predate that. I mean, of course, the first languages the first language was sort of caveman speak.
Yeah, the oldest known written language was Sumerian.
Written. Yeah. I think I don't know. I'm not 100% sure. I've just heard of it before. I don't know all the details, but so I like to imagine there's going to be like a Neo-Indo-European of like all the languages sort of merging back together. Yeah. Anyway, so I guess that's it for Pluto, unless you have anything else to add.
I like it. Do I think it should be a planet? No. And we were talking about this, about how when we say we don't want it to be a planet, that's not a diss on it. That's just we want the dictionary to be enforced as it should be.
Yeah, exactly. Exactly. It doesn't need to be a planet. That's what I'm saying.
We have all the love in the world for Pluto, but it's not a planet.
I think Pluto will have like they'll care a lot about Valentine's Day as a society because of the surface feature.
Of the heart. Yeah, that'd be a Plutonian holiday. You drive out to the ice heart.
The heart.
And
exactly.
But
with your Valentine.
Yeah, you have a picnic in the park. All that.
Yes. But yeah, exactly. But yeah, with the planet thing, I feel like, why does everyone care so much about labels, man?
Yeah, honestly, man, it's crazy.
It's just these labels,
I gotta get my guitar and just break the song's flow. Conversation.
Labels.
Yeah, come on, man. It's just dwarf planet, regular planet. It's just a rock,
It's all the same. We're just living our lives.
Exactly.
Yeah. Exactly. Space hippie. Do you think that's
space hippie? Yeah, it's definitely going to be a thing because you're going to get pockets of people that are just doing their own thing, You're going to get pockets of people that have just established their own mini colony on their own, on a ship or on like a temporary base, and you're going to get they're all just going to be a bunch of hippies just hanging out in space.
I mean, it's bound to happen eventually, right?
I think they're actually myths. I think myths might make a comeback. Because
I like that.
When the first myths that were created were of storms in the sea, right? They needed an explanation for thunder, and they needed an explanation for why the sea would sometimes break their boats. So, I think going out into space is kind of like a new medium, and I feel like in the hippie commune, they would all be talking to each other. They'd be like, one of them would be like, "Have you heard of the Oort Cloud ghost?" And they all huddle around their heat lamp, and they're like, "The Oort Cloud ghost? I thought that was only a myth." And he's like, he takes a long swig of his Beetlejuice, and he's like,
"Yeah,
no,
exactly.
It's real. I know, because I saw it."
Yeah. I lost a hand to it. And like, oh.
Yeah. Oh. But
like my metal hand.
Yeah. But he was like, but I was immediately able to replace it.
Yes.
Like, oh.
Exactly. Yep. Space pirates with robot hands.
Space pirates with robot
instead
hands.
Of hooks.
Yep.
That's the thing. Anyway, so that's Pluto. Let's go to the next one. Haumea. Look at this absolute mad lad. Haumea just said, "Spherical? Why would I do that?" It decided to be an ellipsoid. It's very weird. It's an ellipsoid. Deal with it. Like, it's kind of insane. So, Haumea is a triaxial ellipsoid, which means that it's basically a three-dimensional oval. So it has a different axis for its length, its width, and its height. So, a sphere has the same dimensions in each direction, but Haumea is triaxial. So that's what that means. And the reason for this is that it has a very short day length. Get ready for this, Sebastian.
Mm-hmm.
It has a sidereal rotation period of 3.9 hours.
Wow. That boy
That is
spinning.
Crazy. He's really spinning. And so the result of that is this elongated shape as the sort of mass of Haumea gets dragged out by its
do we
orbit.
know why it's spinning that fast? Like, do we know that something hit it,
Um,
or that it just
yeah, let's see.
rotate
It
throughout
just
space?
is.
Just is.
Okay, let's see. There's a section about rotation. It doesn't. Oh wait. Which can only be explained by a rotational period of this length. This is faster than any other known equilibrium body in the solar system, and indeed faster than any other known body larger than 100 kilometers in diameter. Wow. It doesn't really say why it happened. Oh wait.
Huh.
This rapid rotation is thought to have been caused by the impact that created its satellites and collisional family. So there you go. So what that means is Haumea, you see, it's got two satellites there. One of them is called Hiaka. I do not know. It's Hawaiian. Anything that has a Hawaiian name, you can guess it was discovered by I forget what it's called, but it's the Hawaii telescope. There's a huge telescope in Hawaii. Okay, the other one is Namaka. But yeah, so anything named after something Hawaiian, and anything that sounds Hawaiian was discovered by this one telescope in Hawaii. So that's Haumea. But yeah, so Haumea has it has a semi-major axis for its orbit of about 43 astronomical units, so it's farther out than Pluto, but it also has a fairly high eccentricity. All of these objects have very high eccentricities relative to the planets, but the Kuiper Belt objects have very low eccentricities relative to the next things we're going to talk about. And so Haumea gets as far as 51 AU and as close as 34 AU. Also, let's see. It has a surface gravity of... Oh, I don't think it lists it. And that makes sense, actually, because... Oh, wait, no. Equatorial surface gravity, 0.242 meters a second squared, so that's about 2% Earth gravity. But it would vary based on where you are on the surface. If you are on the one of the two peaks, I guess you could call it, on the long axes, you would experience much lower gravity because the centrifugal forces will be counteracting it,
Yeah.
So this is just a weird object. I kind of want to go there too. I want to take
just
a
spin
Kuiper
around.
Belt tour.
That'd be nice.
Just spin around.
Just
every 4 hours. Could you imagine that? So that's like it's just interesting. So that means 90 degrees, like just in terms of what the sky would look like, I'm wondering if it would be perceptible, the rotation of the sky.
With 4 hours.
So that would be 90 degrees per hour.
Yeah, I feel like if you stared at it for like 5 or so minutes, you could probably notice that something went like a couple of centimeters over. But I feel like you couldn't just like give it a stern glance for like 20 seconds and see it.
Each minute is 1.5 degrees of rotation here.
So if you stare at it for 5 minutes, then you get 7.5.
But think about that. So the width of the moon is 0.5 degree. So in 20 seconds, any object in the sky, any object on the celestial equator, I should say, will move like a distance equivalent to the width of the moon. I feel like you could notice that. I don't know. I feel like you could notice that. Of course, I emphasize celestial equator. Because if you're looking at an object, the North Star obviously doesn't move at all. So if you're looking at an object that's, say, 60 degrees up from the celestial equator, that would give you, it would move at about half the speed, the angular speed. I don't know, it's interesting. So anything on Earth in the Terran sky moves at about 1/6 the speed. So for something to move a moon's width requires 2 minutes, which is I feel like I don't notice that, just very crazy. Also, what would make it better is that on Haumea, there aren't trees like there are on Earth. It's just barren rock. So I think it would be easier to tell when something goes below the horizon.
Mhm.
Just in general, less atmospheric blurring. But yeah, that would be so crazy to be on Haumea. Let me just look. It's crazy. I don't know. I can't get over it. It's egg shaped. It's
It is.
weird. Um, but yeah, I guess other than that, there's really not much about it. But I would say that's a very significant thing. Again, it's like Haumea doesn't need to be a planet to be cool. It is triaxial. It rotates every 4 hours. That is just
Is he?
yeah. It's very
And yeah,
cool.
I feel like this would be a tourist destination.
Yeah, exactly. This
100%.
has to be a tourist destination. Another thing, the temperature here, just like on Pluto, the temperature is less than 50 Kelvin, which means like diatomic nitrogen, I believe, freezes. Like freezes. You know, we have liquid nitrogen on Earth, like, but this is frozen solid nitrogen. I think oxygen too freezes solid. Let's see, oxygen freezing point is let's see, freezing point Kelvin. 54.36 Kelvin. So this is colder, just colder than the freezing point of oxygen. Oxygen itself will just fall to the ground. Um, what else? You've got methane. Let's check methane freezing point, 91 Kelvin. So out here in the Kuiper Belt, this is just in general, everything is frozen other than like diatomic hydrogen and helium. So diatomic hydrogen has a like freezing point, I believe, of like 21 degrees. Let me see. Hydrogen. Let's try melting point. Kelvin. So hydrogen, yeah, 13.99 Kelvin, and then when it comes to like boiling point, let's see what that is. 20 Kelvin. So hydrogen would still be a gas out here, which is crazy. Like hydrogen, it takes very cold temperatures to turn hydrogen into a liquid. And then helium, of course, will also just be a gas out here. But those are like the only substances that will be a gas. Everything out here is just a solid.
Yeah.
So yeah.
Yeah, I would go to Haumea. You know?
I would totally go to Haumea. I mean, like, because it's so weird because on the sort of peak of the tallest axis, right, the horizon, which would be much closer to you than if you were on the peak of the shortest axis. You know what I mean? Because it's flatter on the top than on one of the sides. So, like, you'd get a horizon just standing on the ground that's, say, like, the horizons are already very short because it's a small object, but, like, the tiny horizons would be maybe even less than 1,000 feet away. And then on the poles, you would get a horizon that's maybe a mile away. So yeah, just a very interesting world, all of these. Very interesting. I would love to visit these places. Let's make it happen.
Let's do it. 2023. Haumea road trip.
Yeah, 2023. Haumea road trip.
Yes.
Yes.
We build a road to Haumea.
Yeah, we got to build a bridge to Haumea. I think that's a great idea.
Yeah. So now we can go on to Makemake.
Makemake. Another one discovered by that one telescope. I think it's called the Laniakea telescope. Let me just check because I'm going to be referencing that more. Hawaii Laniakea telescope. I did not spell that right. Yeah, oh wait, no, it's the Laniakea supercluster. Oh, it's literally just called the Canada, France, Hawaii telescope, located on Mauna Kea. Okay, so that's the telescope. Anyway, so Makemake has a surface gravity of less than 0.57 meters a second squared, so that's 5%. It has, let's see, it has one satellite, and it's called MK2. So yeah, this is just another one. I don't have as much about Makemake, I will say, but
here we go.
Again, it's
fun
just
facts.
ice and stuff.
It was named after the Rapa Nui god of fertility.
Yeah, Hawaii.
Yeah, I'm pretty sure that
there's methane. There's methane here. So frozen methane, of course, but all this kind of stuff. These worlds are just so fascinating in that they're just cold and frozen. I guess, like, how would life be on one of these objects? What do you think?
I think it'd be nice because no one else would be around, but it would also be, I don't know. What was the gravity on Makemake?
5%.
5%. So
you could set up a. You could probably just bore cylinders, like, you know, the ice cores that we do in Antarctica.
Yeah.
Basically do that, but make it like 10 kilometers wide, and then just set up a cylindrical habitat in there, and no one would be the wiser.
Yeah.
No one would notice the 5% gravity, like, tugging them towards the wall. Everything would be slightly off kilter, but that can be adjusted for. I mean, people live in San Francisco.
Yeah, I mean,
you know, and that whole city is like.
Yeah, if you can live in San Francisco, you can live on a dwarf planet.
Yeah, exactly. That's the lesson. So.
Yeah, Makemake.
Yeah, but it would just be interesting, I guess. Yeah, again, you have the problem of melting into your surface. So you gotta, I don't know, insulate to make sure that you don't just melt into the ground, because that would be not ideal. But yeah, I just like the idea of, you know, venturing out of the colony, doing a little like spacewalk, just bouncing around on the surface of one of these dwarf planets in the ice, go and seeing like some crater. You could probably like snowboard off of the craters, you know.
That'd be
like,
heat.
That'd be very
that'd
cool.
be really
right.
nice.
Like that would be awesome.
What you just said gave me just like a mental screenplay of someone leaving a colony, like some teenager gets in a big fight with the other people on the colony, like his parents or whatever, and he's like, you know, screw this, and so he takes his own private ship, and he's been told his entire life, do not go to Makemake. And he's like, I'm gonna go to Makemake, and he goes there, and he finds the body of Ronald Reagan. Anyways, smaller objects.
No, it's like that's funny. It's like the ghost of the Oort clouds there.
Yes, the ghost of the tomb of the ghost of the Oort Cloud.
Yeah, they're gonna have a Davy Jones locker equivalent.
Exactly.
Yeah. All right, so yeah, smaller objects. This is kind of like asteroids, except they're ice. They're iceroids. They're these icy bodies, but it's always dirty ice. It's never sort of pure, like, I don't know, Fiji water. You know, it's always just, it's more like, well, I was gonna make a joke, but I don't want to insult this one town. I mean, yeah, it just seems sort of in poor taste, like the water there. But
oh my god.
But anyway, I never said the name of the town, so
yeah.
No. But the point is, the ice is going to have significant amounts of like rock and stuff in it, so it's not. So you have to purify it, of course. It's not what we think of as like snow. Even snow is pure until people drive on it, and it's just slush on the side of the road, and it's all brown. But that's sort of what you get out here. It's all mixed in with silicates and dirt and stuff. It's just another material. Ice is just another material. Like ice, we think of it as something that melts, but that is not necessarily the case. It could just be another building block. Like, we don't remark about like how, like, oh my gosh, the gravel is mixed in with the dirt. What are we going to do? You know, that's just the environment. So ice and rock together. What's likely to be done out here is, I would say, pretty similar to what would be done in the asteroid belt. Is you go through the asteroid, or the, I don't know what you would call it, the Kuiper Belt object, the KBO. So you go through the KBO and you mine out all the silicates, the iron, anything you can use for building materials. You construct that into a large shell, and then that shell can be spun up into an asteroid colony, into an O'Neill cylinder type situation. And so, of course, you can essentially just hitch on to the icy object that you're next to, and that's just your source of water, nuclear fusion, just anything. So you have your town tied up to your town's aquifer, essentially. So yeah, you could probably get little communities of different colonies that were all built using the materials of the same ice KBO, and so they would all be sort of hitched up to the KBO in this sort of ring and sort of shell around it, all sort of feeding off of the ice in the center. What do you think about that?
Yeah. Be nice to live in a little ice world. Say you're on Venus, right? I'm gonna live on Venus. I'm sitting in my own Venus household. Very I'm gonna say it's a modest home, not too big, not too small. Got everything I need. Got my jazz. Got my pool. Got everything I could ever need. A kitchen, and I got 2 ovens. But it's a little hot out, Venus, kind of a hot place. So I'm like, you know what I need? I needed an escape. And so for a week, I go to one of these smaller objects. Ice World. I have myself the time of my life.
Yeah. Ice Worlds would be fun. But yeah, so you could get these little sort of conglomerations.
Yeah, I know. I just got hit by this. To be the only person on a planet. Imagine that. You go to a planet that, A, you are just the first one to be on that planet. And B, you are the only person on that planet. Because I just got a mental image of me sitting on one of these ice worlds. They're not even a world, but me sitting on one of the ice worlds, just playing my guitar to absolutely no one. Pretty.
And there's not even an atmosphere, so it's just sort of it's just vibrating in space. I don't think anyone would ever be. Well, I mean, of course, it would happen, but I don't think it'll be routine, because if we look at the Apollo mission, we sent 2 people there. We're always going to be sending. And future missions to ice worlds are probably going to have more people.
But
we send a dozen people.
But when space tourism increases, you're going to get people that just go off,
Oh yeah, totally. If you can get your own private, your own private jet, I mean, you'll run in with the FAA, you know what I mean? But, but it's interesting because, my father and grandfather at one point had licenses, and my uncle had licenses to fly small crafts, small airplanes, not passenger planes, but just small airplanes. And they sort of say, within their own lifetimes, that it's gotten more controlled, how you can sort of just fly around. In the past, you could just fly around and just call in over your, communication device. I don't know much about planes, but you could call in to the airport and just be like, okay, I'm gonna land now, and they're just like, all right. But now every airport has a landing fee that's really high, and fuel prices are higher, and all the small planes cost more, so it's becoming sort of difficult to do that. So I imagine you could get a similar situation with the ice worlds, where it starts out and people might just take their own private their private spaceships and just land on some barren ice world that no one's ever been to. But then as things get more developed, there's going to be more procedure around it,
Yeah.
Again, it's pretty dangerous. I mean, when it comes to aviation deaths, I'm pretty sure 99% of aviation deaths come from small crafts rather than passenger planes.
Yeah.
Passenger planes are much, much safer. They almost never go down. But the only, like, I would say the majority of passenger planes that have gone down because of like intentional acts of sabotage, you know,
Mhm.
rather than just like a malfunction. Um, so yeah, but that's another reason why we send two people. Is like, what if you're bounding along on your ice world, and you're jumping really high, and then you didn't notice that there's a crater there, and so then you land in it, and you break your ankle, and then you break your leg, and you're just there, and you're like a kilometer away from your spacecraft, and the oxygen's running low, and you have to like crawl out, and you're like, oh no, I'm not going to make it in time. What would you do in that situation, Sebastian?
I
I would
would I would go live on YouTube.
say, someone come help me.
Yes, I'd say, hi everyone, this video is going to be a little shorter than usual.
Yeah, exactly. But like, that's why we send two people usually,
Yes.
because you always want to have a backup. That's why there is, just like everything in life. That's why you always keep a backup copy of files.
Yep.
That's why there's the whole like U.S. Like line of succession, and like we have a
Yep.
vice president. That's why
an
like
emergency
redundancies.
an
That's
emergency
why, yeah,
cookbook, all of that.
emergency cookbook, first aid. Although I will admit that it's sort of like non-redundant. Where's the second aid? What if you misplace the first
Ooh.
aid? That's a major flaw in the system that people have not realized yet, and it must be patched.
That'd be hysterical if the ambulance pulls up and you're like, oh, thank God, first aid, and they're like, nah, we got our budgets pulled with second aid.
Oh no.
And
They
like,
only take you to like Boston. Like, they just take you to a Boston hospital. You're in like, Oregon. They
Yeah.
drive you across the entire country. They're like, we only operate it.
You're like, my friend broke his arm, can you set it? And they're like, we'll set it halfway, you can do the other half. You're like, that's objectively worse.
Oh yeah. We'll set it halfway, and then you must pay us if you want us to set it the rest of the way.
Exactly. That's second aid.
That's second aid. Yeah, exactly. But anyway, so those are the smaller objects.
Yeah.
Actually, wait, I just want to say briefly that the first like I learned this a while ago, that the first firefighting like unit that ever existed was in Rome, and they were basically a company where they would go to a burning house, find the homeowner, and ask them to sell them the house for like 10% the cost of the house. And if they didn't, then they wouldn't put out the fire. But then if they did, they'd put out the fire and make a profit, because it's like, okay, the fire has made the house like drop 70% in value, but we only bought it for 10% of the value, so we have made a gain. Like
that is the most live right company in literal history.
It is. It really is. I imagine that is how the anarcho-capitalists intend the public utilities to work. But it's just funny because it's like fair enough, because like no one had insurance, so it's just like someone should have invented an insurance company. They would have. The first person to do that probably would have gotten a lot as well. But yeah, anyway, so that's just a brief tangent. So now let's go to Neptunian resonances. So a lot of the Kuiper Belt objects reside in Neptunian resonances. I think it says here that Pluto is in a 2 to 3 Neptunian resonance, which is one of the stable ones. Some resonances are stable and others are not stable. So 2 to 3, if you can sort of like imagine it, like whenever Neptune passes near Pluto, like the tugs sort of cancel out. So it'll tug it to the right, and then half an orbit later, it'll tug it back to the left. And that evens out and makes a 2 to 3 resonance more stable than just an average orbit. But then you've got like a 1 to 2 resonance, which is every time Neptune passes, you're tugged to the left, just more and more, until you just fall out of that orbit. So it's an unstable orbit. So some of the resonances, you will see a lot of different Kuiper Belt objects residing in the same resonance, but then in other resonances, there will just be none. That's sort of like the asteroid belt has a ton of resonances with Jupiter, where Jupiter sort of carves out these sort of gaps in the asteroid belt. The rings of Saturn, what's it called? The Cassini division, I think, in the rings of Saturn is caused by Titan and Titan's resonance. So orbital resonance is a very big phenomenon all throughout space, but and so the Kuiper Belt is no exception. You've got the resonances. And what that means, I guess, it doesn't really mean much, but it means you'll have a lot of stuff at the same distance from the sun. But again, the orbital eccentricities and the orbital inclinations makes it so that it's not just like they're all like in line moving around the sun, you know. They're just moving around the sun at the same rate, what happens to be the same rate, but they could be at like different angles to each other. It's a mess. But it is significant just in terms of exploration, is that we would expect to find a lot of objects in the 2 to 3 resonance range. So like if you have some sort of, I don't know, early like explorers, and there's probably going to be a profit incentive of like whoever finds it first and like stakes a claim can get the resources, you know. So you could have people sort of prowling the resonance ranges looking for new Kuiper Belt objects to claim.
Yeah. I want one. I want to claim it.
I want to claim one as well. Yeah, that'd be pretty fun. So next we've got The Neighborhood. Oh yes.
The band.
Yeah. So
they got exported to space. They're floating around.
Yep. They're out there. This is just sort of a description of what life would be like out here. So it is estimated that the Kuiper Belt consists of 100 million. I don't know. I wrote myself notes, and I wrote 100 million in numerals, and then the word million afterward. I don't know why I did that. Because then that makes me think 100 million, but it's not. It's just regular 100 million. So 100 million objects spaced out on average 10 gigameters apart, which, you know, 10 gigameters is what, 10 million kilometers.
Mm-hmm.
So that is a bit more than the distance from the Earth to the Moon, I believe. So it's like 5 times. It's about the distance, I think, to the edge of the Earth's Hill sphere. So you've got a lot of space out here. And the sun, again, is 1/1000th as bright, so it's negative 19.2 in apparent magnitude, which is pretty dim. But it's still significantly brighter than anything else in the sky, unless you have a very nearby moon. Like Charon, I think, is very close to Pluto's surface, but just like in general, it's still going to be the brightest thing, but it's dim. There just aren't many brightest things out here. And so, yeah, it's just an interesting space. So it's like your nearest neighbors are going to be, you know, a planetary system apart from you, a planetary system away. And your neighbors are also going to be constantly shifting because different eccentricities, different inclinations. The objects in the Oort cloud are just moving at different rates. So your nearest neighbor today, you know, a year from now, might not be your nearest neighbor. I mean, I guess that's just true of normal reality as well. But this is between like towns. You know, this is town-sized objects. So we've got essentially city-states, I would imagine. Like in terms of government structure out in the Kuiper Belts, I imagine each little Kuiper Belt object would be a city-state, and they'd probably form loose federations. But the thing is, there are no like permanent borders here.
Are you gonna make Rudengrad a real thing?
Rudengrad, yes.
Rudengrad, a real, just a city-state floating around.
Yep, I want Rudengrad. Yeah, it's funny. I know. I mean, my name is like, it's very close. You've got the IN.
You do have the IN, and that is the most
that is
necessary part. I have the AN, unfortunately, which does not qualify me to be a Russian czar.
Yeah, exactly. Not even a czar.
Not even a czar.
Like a
premier, more like.
Yeah, a premier. I think that's what it was. Well, because think of that. You've got Leningrad, Stalingrad.
Stalingrad.
Why not Rudengrad?
Yeah, Rudengrad. Yeah, right there.
Yeah. I mean, if there's enough space, 100 million objects reminds me of like 100 million objects. That could be every 70 people can get their own Kuiper Belt object.
Wow.
So you just have to be the leader of 70 people to get your name on an asteroid or a Kuiper Belt object. So that's pretty cool. But yeah, so just in terms of environment, again, you're going to have city-states, loose federations. There might be like these feel more like trade guilds to me than like anything. Maybe like loose military alliances.
Mm-hmm.
I don't know, but the problem is like when the orbit of another Kuiper Belt object is gonna like have like a flyby with yours. Like if they're part of a country that like, oh, you're locked in the midst of a like Cold War,
Mm-hmm.
like it's not really tenable out there because everything is all mixed together. So you don't want to like things are going to have to be sort of cordial. People are going to have to be polite. The different Kuiper Belt city states, there's going to have to be a sort of common understanding out there.
Yeah.
I don't know. There might be minor conflicts, I imagine. Say like an unclaimed world is about to pass through like nearby to a few different city states, and all those city states at that moment all claim it and like try to like bring it into their sort of little clump of matter. You could have a conflict over that, but those are like brief because in a year's time, that small object, if no one claims it, would be gone. All the neighbors will have dispersed, so it's just like no permanent like alliances or I guess enemies can really, grudges can't really sustain themselves. It's going to have to be like the Kuiper Federation.
Yeah.
Yeah, it reminds me of sort of like, I mean, it reminds me of Dune a little bit. I wonder, do you know what like country or was Dune's like government structure based on? Or it probably wasn't based on any at all, but
it was you had dukes and you had the emperor. So you're looking at kind of like the hyper monarchical republic that you kind of get in Star Wars, how there's like the emperor of the entire like galaxy, or
yeah.
whatever the hell Palpatine his full title was. So there is an emperor, and then you get powerful families that each have their own quote unquote kingdoms, which is just a bunch of planets, So
yeah.
Right there, you're looking at those are kind of the nobles from the times of serfs that would just own incredibly large plots of land. Obviously, other people are living on them because they're such massive plots of land, but they are the owners of that. So you're really looking at kind of feudal times is probably the best comparison.
Yeah.
With
like two nations in particular, I would say that I was really reminded of was like Tokugawa Japan and the German like Prussian Empire.
Yes.
Like
I would definitely. I'm much more read up on Prussia, but I don't know about Tokugawa. What's going on there?
That's sort of, it was like you would have the Emperor of Japan, and then there were the different like shogunates or something. I forget exactly. But there was a lot of there were sort of individual kingdoms across the islands of Japan, and it's like, I think it was that each king, I forget what the word was for king, but whatever, they had to sort of spend half the year in the capital and then half the year at home. And like their families had to stay at the capital. It was like one of those, they're like essentially hostages to keep the loyalty of the kings. But
that's a really good comparison to bring up, because obviously with these city-states you're going to get people that want to branch out, people that want more, and then the leaders of the city-state, like the mayors, would want to branch out and all of that. So it would, and the deals are made between different cities, so there might be a merger. So eventually you're going to get just two very large forces kind of against in any given like area.
Yeah, that's interesting. I mean, because with this, like, I imagine Pluto, Eris, well, we'll talk about Eris, but all the big objects are sort of going to maintain their own sort of thing. But yeah, they might get satellites. Like you might have different city-states decide to just enter orbit around Pluto just because for the economics of it.
It's well known that Neo Angeles is orbiting Mars, but Pallas Prime is the outlier because Pallas Prime is its own city, not in orbit of anything except for loosely the sun. So
yeah, but you see the thing is, right, with Pallas Prime or with any of these smaller objects, is that any individual object that gains prominence, even if it doesn't have a gravity well, it will sort of attract other cities almost as if it had a gravity well. And that gravity well is just riches, trade.
Well, that is the Pallas Prime way. It has assimilated many cities into its empire.
Yep.
They're a bunch of arrogant schmucks.
Yeah, exactly. So this is just, I guess, part of the point is that not only are objects just randomly moving relative to each other, but the smaller objects are easy to move. Like you can actually change course. If you're about to fly past, say that two mayors, just two mayors, like not even the cities, just two mayors have a personal feud. Like you could even get just a sort of nepotistic type of thing where one mayor sort of like intentionally like changes course of the whole asteroid colony to avoid seeing the other mayor. Like you could do that because it just takes some rocket boosters, and again you've got hydrogen, and you have water, right? And water is the best rocket fuel. Well, not the best, but it's a rocket fuel. So because you can turn water into hydrogen and just throw out the oxygen essentially and use that for nuclear fusion. But even if you don't have nuclear fusion, right, you can electrolyze the oxygen and the hydrogen and then burn it again, and that's an efficient rocket fuel. Of course, the whole process, you can't gain energy from that because it takes energy to separate the atoms or the molecules, and then it releases energy when you put them back together. But in terms of rocket fuel, if you make it and then release it all at once, that's sort of... But the point is, these things are highly maneuverable. So you could get like little city-states that like join conglomerations. So it's like... So here's one example, is that I believe the island of Samoa was like... Many years ago, Samoa was on like a -12 time zone. It was on the time zone -12. But then, basically, their government just noticed one year, like, we're trading more with Australia now than we're trading with America. So let's just change to +12. And they just did.
Wow.
So they went from -12 to being a bit behind America's time for easy trade to +12. Being a bit ahead of Australia's time for easy trade. And it was just like that, just a matter of convenience, right? It's really interesting. I think they skipped December 30th, like of 20-something. So it was like December 29th, December 31st, and then New Year. And so that's just essentially what you could have with these asteroid colonies. Of course, an island on Earth cannot physically move, but changing time zones like that is probably the closest equivalent we have. So these little like city-state objects, say it's attached to Pallas Prime, but then it realizes like, oh, this city, like, I don't know, this Haumea Haumeaville is doing better this year. They're experiencing a ton of GDP growth. Let's actually go over there. So that would be interesting. I could see sort of like stock markets that are essentially just based on the success of a city. Sort of like how you have GLD or SLV, like that track the price of gold and silver. You could have like Pallas Prime stock that it's like the GDP of Pallas Prime is proportional to the worth of the stock. The Kuiper Belt stock.
That'd be
exchange.
Nice.
Yeah, the Kuiper Belt Stock Exchange.
Until a bunch of people on Reddit get the Kuiper Belt Stock Exchange to crash.
Yeah.
Because
I don't
they
think
all
they're
invested in Mite Bites.
Here's the thing. The Kuiper Belt Stock Exchange would have to, like, not allow day trading. There could not be day trading on the Kuiper Belt Stock Exchange because it takes light itself a few hours to span the width of the Kuiper Belt. So if you were to say, buy a stock at $50, and then the request gets in 3 hours later, when the price has gone up to $100, and you come back and you've only gotten half the stock you expected, that's not going to work well. No one would trade in that system, So there's going to have to be, if there's going to be a unified Kuiper Belt stock exchange, it would have to be like all orders must be in at midnight universal time. Mm-hmm. And then just one act of trading occurs every day, which is just fascinating. So, imagine that. It's like the stocks would just go up and down, jump or fall in one instant every day. If you were to have some sort of viable Kuiper Belt stock exchange. But again, it's not necessarily going to be a unified thing. It might be Pallas Prime has the Pallas Prime stock exchange. And then that would be another reason for different conglomerations to move closer. So you could actually end up getting a sort of cleaning up of the Kuiper Belt, whereas right now you've got 100 million objects just roughly evenly dispersed, and it's a fairly rocky area. You could end up with just a few large conglomerations that have a lot of different objects gravitationally or even just physically bound. So that's how the neighborhood might be out here.
Yeah.
All right, so then finally, we've got the Kuiper Cliff, which is just the boundary at the Neptunian resonance of 1 to 2, which is, I think it's the least stable resonance. And so since it's the least stable resonance, the number of Kuiper Belt objects significantly drop off, but you would expect it to be like the density to be sort of V-shaped, like you get like you're closer to Neptune, but then it's just the 1 to 2 resonances where no one is, but then it comes back up. But for some reason, it just goes down and it just stays down. So the density greatly reduces, and that's sort of what we have decided. That's what we've termed as the edge of the Kuiper Belt. So anything outside of there is not part of the Kuiper Belt. It's either part of the Oort Cloud or a few other things that we're going to get to first. So, all right. So shall we begin? The scattered disk. So the scattered disk is composed of objects that have more elliptical and more inclined orbits than that of the Kuiper Belt. It goes from 30 AU to 100 AU from the sun approximately, and so you notice that overlaps with the Kuiper Belt. So any given scattered disk object may be within the Kuiper Belt, but it's not part of the Kuiper Belt, which is confusing. But again, you have to think about this in like space terms. A scattered disk object that happens to be in the Kuiper Belt would be like an airplane flying over Kansas, right? You wouldn't say the plane's in Kansas. You wouldn't say the plane is part of Kansas. It's over Kansas right now, and in about 15 minutes, it's not going to be. So that is how the scattered disk objects overlap with the Kuiper Belt. They're not part of the Kuiper Belt, and for the most part, they, like most of the year, local years, which is hundreds of years, they are not even within the Kuiper Belt. It's just sometimes they might cross into the Kuiper Belt before leaving. And that's sort of, that's even Pluto occasionally gets closer to the sun than Neptune. For the most part, it's farther, but its periapsis brings it just closer than Neptune. So you wouldn't say Pluto's closer to the sun than Neptune. That's just how it is. That's just space for you. It's a very, very wacky environment.
It's volatile. That's what it is.
It is volatile, yeah. So let's begin with Neptunian Perturbation.
Wow.
So look at that.
That's what my computer looks like with all of its wires just out.
Yep. So this is like the orbits of a ton of different significant scattered disk objects.
This right here proves entropy.
Yeah. This proves entropy. Actually, this diagram is incorrect because I see Sedna in this diagram, which means that this is actually the next one that we're going to talk about. It's actually the detached objects, but the same applies. The same sort of thing applies, and that is that the resonances in the Kuiper Belt show evidence that Neptune's gravity has a great effect on these objects. And so whenever a Kuiper Belt object happens to go a little bit too close to Neptune, it might get flung out into the, I mean, it's already in the outer solar system, so it might get flung out into the outer solar system. It might enter the scattered disk or the farther out detached objects where it gets a very inclined, very elliptical orbit, and it's just out there, and it's like, what is it doing? And yeah, that's sort of the process by which these sort of things occur. But whereas in the Kuiper belts, you had like objects would be moving a lot relative to each other, any two objects in the scattered disk are even more so, like moving at different speeds relative to each other and different directions. And it's a lot less dense because of the Kuiper Cliff, so it's not as dense a place. And already the Kuiper Belt, again, wasn't a dense place. It's very interesting in space is that you think, wow, that's pretty like sparse, but then it gets sparser. So many things in space, like, I mean, you know, we would call Pluto a small object, even though it is physically, like on a human scale, it's massive, just because there are much more massive things. We would call the sun is considered a small star because there are much, well, actually, it's a bit of a misnomer that the sun is a yellow dwarf, even though 95% of stars, I believe, are smaller than the sun. It's just that some stars are very much bigger, and those are the ones that we see. So it's like, it's just kind of like that. Space is relative, and so that's why astronomers are notoriously bad at naming things. Mm-hmm. So, yeah. But so let's begin with Eris. Eris is a scattered disk object. And for all of you Pluto diehards out there, if you want to be mad at someone, be mad at Eris for existing, because Eris is the reason that Pluto is no longer a planet. Direct your ire toward Eris. Eris was discovered on January 5th, 2005. Sound familiar? Pluto was demoted in 2006. So don't blame me. Don't blame me. Hate the game, not the player, right? So hate Eris. Get mad at Eris. I want to see a hashtag Eris is over party. What do you think?
Yes. Let's see it.
Let's start it. I'm going to tweet that after the show. I'll
awesome.
Tweet hashtag Eris is over party. But
Eris is now canceled.
Eris, we have just canceled. I feel bad now. We've canceled Eris. So
I'm sorry, Eris.
I'm sorry.
But so it had to be done.
It had to be done. Eris had to pay for its crimes. So Eris has an orbit that has a perihelion of 38 AU and an aphelion of 97 AU. So it really covers the range of the scattered disk. It gets, you know, it crosses within the Kuiper Belt, but then it goes way out there, out to 100 AU, and it has an orbital period of 559 years. So wow. It's good that we're not still doing the whole calendar episode. It's good that we stopped once we got to Neptune with that. Could you imagine a 559-year-long year? You would need, you know, thousands of different months. You'd be like, what month of it? Like, you would probably just end up giving each month a different serial number, like a barcode. Like, oh, what month is it? It's A1P2566. It's like, okay, great. So it's winter. Like, just weird. But yeah, so again, that's probably why they'll have to use just some sort of star date or just use Neptune or something. But other things about Eris is that it is actually pretty large at 2,300 kilometers in diameter, so 1,100 kilometers in radius. That's just how it is. So again, it's small in space terms, but it's big in just human terms. It has a surface gravity of about 8% of Earth's surface gravity, so very, very light. It's pretty much just Pluto, except it's like 5% bigger. Eris is very much similar to Pluto. So Eris has a moon called Dysnomia. I like that name, Dysnomia.
Sounds nice.
I'm not sure if it's tidally locked to Dysnomia. It wouldn't surprise me. So the sort of orbital space elevator setup is probably something you can do on multiple objects out here. But yeah, again, composition is pretty similar, except Eris is more icy than Pluto is because Eris has a larger diameter but is less massive. So that's just an interesting thing. But yeah, it's Eris. So it takes you out to 100 AU. Can you imagine that? So that is, the sun would be 1/10,000th as bright at Eris aphelion, which is going to give you 10 lower on the apparent magnitude scale. So the sun would be negative 16.7, which the moon is like negative 12. So it's a very, very dim, desolate world. It's a great place to go to be alone if you want that. So that's probably going to be. I can see these as like refuges. Like, I mean, this is like the Fortress of Solitude. Honestly, you know, it's covered in ice. It's just an icy base where you go to be alone. It's just interesting because these places would be very, very isolated. We can actually get into the smaller objects, I guess, but yeah. So these objects are all individual. There's just, I don't know how to describe it. It's like you're adrift in the sea, you know. That's I guess how it is. Whereas the Kuiper Belt was like an archipelago, here you are on a lonely atoll, Point Nemo, you know.
Yes.
3,000 miles away.
That's like the farthest possible point, right?
Yeah. It's either the farthest from land or the farthest from settled human habitation. So
something like that.
Yeah. Point nobody, essentially. So that's what Nemo means. But yeah, so these smaller objects, again, the same sort of thing applies about the Kuiper Belt, where you would just use the silicates to construct a base and use the water for water as well as for nuclear fusion. But what also applies out here is that whereas in the Kuiper Belt, you'll have identifiable like nearest neighbors that are just about a planetary system away, and you'll have, you know, unclaimed objects every once in a while will race through your patch of space. In the scattered disk, there isn't going to be as much of that. It'll be so much rarer. It'll be like every few years you might have a flyby nearby some other small object, and you might send a few communications, you know, people might go back and forth a little bit, but unless you plan on executing a merger, that's going to be it. Every once in a while, maybe a tiny, tiny like chunk of ice floats by and you're like, oh, let's grab it. But it's just very, very desolate. Just nothing out here. It's just rare to encounter another world out here. So it'll be a looser sort of thing. There probably wouldn't even be confederations because there wouldn't need to be. You know, there wouldn't need to be any really political ties. Just sort of an agreement of like, whenever you happen to get near to someone, say, hey, don't make any sudden moves, right? We don't want to accidentally crash. Just keep going how you're going. Not much is going to happen. But there's an appeal to that. It's like a rural sort of hideaway.
Yeah. It'd be nice, man. It would be so nice to just have your own place out there, out in the stars.
Right? Like, I think that would be nice. Just your own sort of... It reminds me of, like, this is just a meme I've been sort of into the past week, is Huey Long, the politician from the 1930s who is a bit of a meme. His slogan is, every man a king, but no one wears a crown. That was his slogan. And so
Syndrome.
You could essentially... Yeah, exactly. You could essentially have that out here. The Kuiper Belt and the scattered disk, this is Huey Long's, like, this is the promised land, because out here, you can be incredibly wealthy. You know, you can just build a palace on, you know, palace. But, because, although that's an asteroid, but, you know, I digress. But there's just plenty of space out here. Really, all it is like the greatest shortage, I would say, out here would be a shortage of people or of labor. So you either need to get really good robots, like really great autonomous robots, or you're going to have to pay people a lot of money, which would be sort of untenable. But yeah, so especially considering how isolated these places are and how you'll probably get, say, a group of a dozen people venturing out to some unclaimed scattered disk object, they're going to need a team of like many AI self-operating drones that'll build structures for them and stuff. So yeah, let's go to the next thing. So eccentric. So again, these objects have eccentric orbits. Look at these things. I could watch this for hours. This little GIF right here. So all of these objects have the same semi-major axis, but they have different eccentricities. So they go around in the same period, but it's like different sort of shapes. And the way eccentricity works is that when you get closer to an object, your orbital velocity increases, and when you're farther away, it decreases. So Eris, in its 559-year orbit, really lingers in the top part of its orbit, and it only very quickly zooms through its periapsis. And another thing I would also like to say, and this will apply more later for the detached objects, but a lot of the, when we discover objects in the scattered disk, or when we discover detached objects, we remark, and as we calculate their orbits, we remark, they just happen to be close to their periapsis. They just happen to be on the close part of their orbit. And you might think, that's an incredible coincidence, but it's not. And what that implies is that there are an equivalent, there's a proportional number of objects that are not in their periapsis. And when they're not near their periapsis, they're dimmer because they're farther from the sun, so they're reflecting less light, so they're harder to see.
Mm-hmm.
And so what it implies is that for every object like Eris that we've discovered, there's probably, a dozen other Erises that just don't happen to be in the right place to see them, which means that the Kuiper Belt, the scattered disk, the detached objects, the Oort Cloud are probably a lot richer than we think they are. Untold wealth, that is what is to be found out here. So yeah. So finally we have Homesteads. So this is just the description I was saying before.
Nice. That's such a baller picture.
It is really a nice picture. So you'd get these individual O'Neill cylinders or groups of O'Neill cylinders, but the groups would only be groups because they happen to be built out of a large object. You know what I'm saying? It's not going to be different groups coming together. That would be exceptionally rare. If you wanted a sort of group, you would go to the Kuiper Belt for that. It would be very rare. I mean, over time, it tends to happen just politically. You get political centralization is sort of a trend, I think. I don't know. Maybe maybe it's not, but that's what I sort of think it is. Because if you just look at the EU,
start a war in the comments about this.
Oh yeah, start a war in the comments. But what I mean is is that there's more interconnectedness, I guess, between the nations at the very least. There's more trade relations and stuff, so closer economic ties, globalization essentially. So you're going to have solar systemization here, and yeah. So the sun is very dim; it's just desolate, and eventually, I suppose you'll get clumps and groups that form together, but for the most part, it's going to be sort of isolationist city-states. Wouldn't that be interesting? It's sort of like Singapore, except it would be like the whole world is just a large ocean, and you've got Singapore-sized nations just dotted around.
Yeesh.
And none of them really talking to each other. Just all of them sort of isolationists. So it's just interesting. It would be, George Washington's dream, right? No foreign alliances. Farewell address. So That's what you'd get out here. But yeah, so that's the scatter disk. So next we have the detached objects. Look at them. They are so detached. So their range is 55 to 1,000 astronomical units. They get very far out. And you may notice that 55 is just the very outer edge of the Kuiper Belt, and that's a specific reason, is that the scattered disk objects, they get far out, but then they get into the Kuiper Belt a little bit, but the detached objects get far out and never even get into the Kuiper Belt. And so they are completely independent from the influence of Neptune and the solar system. That is why they are called the detached objects. They're far enough out that the solar system has no significant gravitational effects on their orbits. That is the whole premise. That's why they're detached. But yeah, so we begin with the Heliopause, which is estimated to be about a little over 100 AU from the sun. And this is basically the zone where the sun puts out a constant solar wind that just radiates out into space, and it stops once you get to the Heliopause. And the reason that it stops is that as it radiates outwards and disperses, the solar wind gets much more dilute. It gets much thinner, it slows down a little bit, and just not as dense. And so eventually, just the outward pressure of all the other combined heliopauses, and just sort of all the stars, everything in the galaxy, just the galaxy's sort of ambient pressure, stops the solar wind at about 100 AU. This is one of the things that is considered to be the boundary, the outer edge of the solar system. Here you are essentially in interstellar space. It just depends on how you're defining it, because objects are still orbiting the sun out here, albeit loosely, but they're still orbiting the sun. They very much are in orbit of the sun. However, there is no solar wind. So they're still getting sunlight, yes, but like no solar wind, which is just a very, very strange thing to think about, because there's always solar wind. That is why Mars is uninhabitable. All the planets that don't have magnetospheres are subject to the solar wind. But out here, you are not subject to the solar wind. You are just subject to the galactic wind, the galactic ambiance. And so this on the left is sort of a diagram that gives you a nice metaphor of what it is. You've got the sink, and the sink with a faucet, and the sun is like the area where the water rushes away from the dropped faucet, and then you've got the termination shock, the heliopause, where the water just sort of pools up and drips around. That is what this is. We only have 2 objects that have made it out to the heliopause, and that's Voyager 1 and Voyager 2. Godspeed, Voyager 1 and Voyager 2. Yeah. But this is interesting just because this is sort of the domain of Voyager 1 and Voyager 2. And this brings up the possibility that, eventually we're going to have to probably collect Voyager 1 and Voyager 2. It's really weird to think about, but we're probably going to outpace Voyager 1 and Voyager 2 eventually if we're colonizing the outer solar system, right? So someone out there, someone who is, colonizing the detached disk, they might get the bright idea, hey, wait a minute. If I can just snatch Voyager, maybe I can sell it on eBay for a lot of money, right? So that's going to have to be planned for, because obviously we don't want some rando just snatching it up and selling it to the highest bidder. So it's, the common inheritance of humanity, right? So someone's going to put it in a museum, ideally, which is just weird to think about, because we're like, it's gone, it's out there. But no, we're going to get it back. We must reclaim the Voyagers. And it's just a natural conclusion of space travel, is that everything that we've put out there so far, as our technology improves, eventually we're going to outpace its speed of leaving. And when we do, we're going to have to, collect them. Just like how when people start living on the moon, they're probably going to make all the moon landing sites into museums. So Yeah. But yeah, so that's the Heliopause. So let's begin with Sedna. Sedna is a scattered detached object. Look at Sedna. Just look at the surface on the right. Imagine being out there. The sun out here is so. Let's take a look. So Sedna's orbital parameters. Aphelion, 937 astronomical units.
Jeez.
1,000. That is 10 times the maximum distance of Eris, which was already far. It has an orbital period of 11,400 years, which is just a bit shorter than recorded history, written history. That is just the orbital period of Sedna. 1 year on Sedna. And its perihelion is 76 AU, which is quite the span. But yeah, it's funny. They put 937 AU is equivalent to 5.4 light days. So yeah, this is about 1,000 astronomical units out. And because it is about 1,000 astronomical units out, it means that the sun is about a millionth as bright, 1/1,000,000th as bright at aphelion, because it does get closer. But at aphelion, it is 1/1,000,000th as bright, which corresponds to 100 cubed, which means that it is 15 lower on the magnitude scale. So out at Sedna, Sebastian, that is where the sun is dimmer than a full moon at negative 11.7 units.
Wow.
Negative 11.7.
So would you like to live on Sedna? Would you like to visit it at least?
We gotta visit it. I mean,
we
You gotta visit it. I don't know if I want to live there though.
Road trip. The Gravity Max road trip. We're hitting
trip.
Pluto, Haumea, Sedna, Eris.
Oh my god, that would be the coolest. That would be the coolest series, don't you think? A Gravity Max road trip where we just go live.
Just a vlog from Sedna. We'd be like, hey guys, we're live, and it reaches you guys 11,000 years later.
Well, no, it would reach them 5 days.
Yeah, 5 days. Yeah, right.
If it's going out at the speed of light, but yeah, Sedna, it's crazy. I mean, have you ever stood in the light of the full moon?
Yeah.
Like without any other sort of light?
No, not without any other light.
Yeah, so I have done that.
Ooh.
It's very nice. It's like this was December 21st. This was when the whole Christmas star thing was happening with Saturn and Jupiter like aligning. I believe it was only a half moon actually. But I might be remembering that incorrectly. But there was a full moon. I did this school event that was called Astronomy Night. We had at our school, and they turned off all the lights at the school. But out on the beach, even in the half moon, it was even crisper. I was able to see the Milky Way galaxy. So, but it was so cool. I want to do that again because the beach in my town, it's Siesta Key Beach, is like half a mile long. So if you go all the way, like wide, I mean, from the edge of the sand where there are buildings and stuff to the edge of the water. So if you go all the way out to the water at night, there was a half moon and I could see my shadow, my moon shadow. Can you believe that? That is just crazy. And the Milky Way was up in the sky. So I feel like Sedna would be a great place for astronomy. And to put a telescope.
Yeah. Have you ever experienced total, complete darkness?
What do you mean by total, complete darkness?
Like total darkness, like the darkest it's ever been for me was when we were in like a literal cave, and we turned like our flashlights off because like literally negligible transmittance of light from the sun.
Yeah.
Like literal.
Where were you?
This was in Bermuda. That's where we went into the caves. But there was this other time, and this is probably more accessible than Bermuda. Was this summer. This summer was Zach and I went on our camping trip, and we just went out into the woods at like whatever time, like midnight or whatever, and we're just walking through the woods talking about whatever, and we just find this bench in the middle of this forest, and we're like, we should sit on that.
And you sat on
And
it?
we sat
Oh,
on it.
no.
And then I
This
was
is the
like,
start of a horror
we
movie.
should turn our lights off. And Zach's like, yeah, sure. So we turned our lights off. It was black. You couldn't make out the trees. You could hear the trees, and you could hear everything. It was like your eyes just shut off. Even though Zach was sitting literally like not even 4 inches to my left, I could not see him.
Yep. I mean, I guess the closest thing to that would be like if you close the door to your bathroom at night. I know and you don't turn on the light.
Mm-hmm.
Like, if you when you forget to turn on the light and you're like, oh shoot, it's really dark in here. I got to turn on the light. Like you can't even see your own hand in front of your face, but
yeah, that is complete darkness.
Yeah, obviously that is not as how would you say, like naturalistic as the just your bathroom light. But yeah, I imagine the inside of an asteroid colony, if like the power went out, it would be that dark. Because think about it, there is no source of light. You are inside a hollow rock. Like, there's a scene in my second book where like the power source of this asteroid colony is basically robbed, and so then it's just dark. And it's just like nothing. And that's sort of what's described. But yeah, it's just interesting. Out on Sedna. I want to go to Sedna. So let's talk about Sedna a bit. So Sedna has a surface gravity of it doesn't say. Oh well. Well, it has a radius of about 500 kilometers. A rotation period, interestingly, of 10 hours. So it's got a short sort of day length. But actually, they haven't confirmed. It's either 10 hours or 18 hours. Because it's so far away that it's just hard to tell. But what else? It doesn't really matter, though, because, again, it's just the sun is only as bright as the full moon. So it's like, I mean, I don't care if it's day or night. What's the difference between day and night on Sedna?
There is none.
There is none, exactly. So Sedna right now is very close to its periapsis, which begs the question, what about the Sednas that aren't close to their periapsis? We would not have seen them yet. There are probably hundreds of objects as large as Sedna out in the Detached Objects zone, which is just like, ooh, spooky. That's the Halloween story. That's the ghost of the Oort Cloud. The ghost of the Oort Cloud resides in the forgotten Sednas. But coming up to another urban legend that I imagine will be like a thing in the future, Planet 9. So,
Planet 9, that's where they're keeping all the secrets, man.
Yep. So Planet 9 has been theorized before. It was theorized to explain the perturbations in Neptune's and Uranus's orbit, but it turned out that the mass estimates of those planets just were off, and so it was solved. The discrepancy was solved, but we just happened to discover Pluto based on that, because Pluto just happened to be nearby where Planet 9 was predicted to be. But Planet 9 is theorized as like this gas giant-esque object, less massive than Neptune, but more massive than the Earth, that might reside out here somewhere. And so there is some evidence, some loose evidence for this, is that a lot of the detached objects, like their orbits, appear to be scattered by this object. So their orbits are all, really elliptical, eccentric, and inclined. And so some people theorize maybe they're all like that because of Planet 9, because they have like similarities in the way that they're perturbed, but no confirmation has happened yet. But I imagine this will be a very big urban legend in the future. You know what I mean? People saying like, out there's a Planet 9, and I'm going to find it, because he who finds Planet 9 would be very rich. because there is so much
I'm
hydrogen.
watching.
It's a gas giant.
I'm watching Treasure
Yeah.
Planet tonight. I feel like that's very fitting.
Nice.
But
yeah,
yeah, you just get the space hippies again. That needs to be the name of
Space
a movie
hippies.
that we direct. Space hippies.
yeah.
Guy.
Space hippies, it's just that way.
Yeah, they're sitting around their heat lamp again, and they're like, that one guy, you know, after taking another large swig of Beetlejuice, he's like, "Have you heard of the story of Planet Nine?" They're like,
It could actually be a very
thought it
good
was real.
low-budget film. It could be a very good low-budget film because it's like you wouldn't really have to do much. Like you could just film it around a campfire, essentially.
"Ooh,
Like those sort
that's
of
true."
conversation
It,
films,
yeah,
like, you
it
don't
could
need
just
special
be.
effects.
Yeah, it could just be animated. You know, like it
Yeah.
goes into what the guy is saying, but it's just like drawings of the thing or something like that.
Oh yeah, so you have the conversation would be live action, and then yeah.
Yeah, that would be nice. That's
I've
kind of
been trying to
nice.
think of some sort of like skits to do. I had an idea for like a short film,
Mhm.
but again, junior year is kind of crazy, so I feel like I want to start with something even shorter than a short film, just like a short little, tiny little comedic skit that has to do with space. So I'm just thinking of stuff. So I might make something like that soon.
Yeah.
But yeah, so Planet Nine might be out here scattering all these objects, and if it were, I mean, that would be very useful. It would be a very useful resource. So many people would cluster around Planet Nine. I mean, this changes the entire culture of the solar system when we think about it, and the development of the solar system. This would be like the outpost for interstellar travel, whereas we said Neptune would be that. Now Planet Nine would be that. It would also be the de facto capital of the, you know, Oort Cloud, scattered disk, all this stuff, because it is a vast pile of hydrogen and helium. So very useful resource for nuclear fusion and stuff like that. It would also probably have some moons. You could have a whole culture. And if it doesn't have moons now, if it were discovered, it would get moons because people would start moving their stations to be around Planet Nine. That is where you would see the, you know, Kuiper Belt Stock Exchange would probably be housed on Planet Nine. So, yeah. Maybe it's real, maybe it's not. Do you believe in Planet Nine?
I believe.
I believe in Planet Nine.
That poster.
Yep, I believe. Yes. That is, it's a government conspiracy, man. They're keeping Planet Nine from us.
I keep it Planet Nine, man. That's where you
That's
got.
where the aliens are.
All of the
aliens are
meme.
kept on Planet Nine.
All of the meme of the guys, like the guy, the scientist holding up the thing, and he says, "Finally." Whatever. All of those finallys are on Planet Nine.
Wow. Wow. So they've got. Oh my god.
They've got the card game Dose. They have everything. They have Old Zealand. They have everything you could ever imagine.
Yes. I would like to visit Old Zealand.
It's not a journey that many return from.
It's not a journey. Have you ever been to Doggerland?
I
think we should take a school field trip to Doggerland.
Is that a real place?
It was, but it sank.
Oh.
It is under the North Sea, so it's to the east of Great Britain and north of like Germany and the Netherlands. Like Britain used to be attached to the continent, and so this whole like area of land was called Doggerland.
Wow.
And it sank. It's hypothesized that Doggerland might be like the reason the Atlantis myth came into the cultural lexicon.
I thought that was because of New Zealand, because that was like an entire continent that sank.
Oh, because Zealand. Well, people weren't around New Zealand. I mean, there were.
Well, they were.
Because didn't Atlantis come from like Greek? You know, Atlantis came from.
I don't know.
Like Aristotle, or Plato, or one of the ancient Greek people. They didn't know of New Zealand, but they could have known about Doggerland because
that's true.
It's in Europe, you know. That's Doggerland if you want to present again. Basically, as the ice melted, dude, look at that. Scandinavia was attached. Like there was no Baltic Sea. Like that's just an interesting map, to be honest. So that's
Dogger Bank. Henlo, one money pools.
Henlo. Much Doggerland. So Like, it's just Doge. It's just
It is.
like I kind of want to go to Doggerland just for that
Yeah, we
reason.
go
It's
back
just
in
Doge
time to
memes.
Doggerland, and it's
All
just
just Doge
it's
memes.
all Doge memes.
I imagine it would be a utopia,
It
a
would.
utopian
This
society
was
of
this is
Doge.
the only functioning society. Like there was
The
no
only functioning
crime.
society in history. Yeah,
Yeah.
they use Dogecoin as currency.
Yes.
Yes, Doggerland, the ancient Doggerland. Anyway,
Anywho.
so yeah, that's Planet 9. So next we've got smaller objects.
Which
So,
is
yeah,
which
look
is
at-
not a high bar.
Yeah, that's not. But yeah, look at all these orbits that just happen to be lined up like this. It sort of looks like Planet 9 could have scattered them. But again, it's probably just coincidence. So
Probably. But that's what they want us to think.
that's what they want us to think. But yeah, so I don't know. I mean, it's just smaller objects. It is just even more isolated than the scattered disk. As I was saying, the scattered disk was isolated. Like, these are the ultimate isolationists. These are the Woodrow Wilsons. You know, they are all out here being isolationist. Well, isolationist, that's what he campaigned on, but then he wasn't. Well, he was at first. Sorry, I'm just on that unit in U.S. history.
It's all good.
Now we're on. Now we're on FDR. We just started. Apparently, the phrase "brain trust," like you've heard people say that, right? The brain trust.
Yes.
Have you heard that phrase?
Yeah, I think so.
I think that originates with FDR, and if it doesn't, then it originates before FDR. But I saw in the textbook that it's like they nicknamed the like New Deal people that he brought in. They called them the brain trust.
Huh.
And so like that's where that phrase starts. I do not know. But yeah, anyway, so these smaller objects, all isolationist, just the chances of encounters just become increasingly rare. So you've just got these small objects. I mean, same thing as before. There's not much to say here, to be honest. But so yeah, let's go to the next section, the stepping stones. So out here, the sun is 1/100,000th to 1/1,000,000th as bright as it is on Earth, which gives you, negative 14.2 to negative 11.7 apparent magnitude, which is, again, about the apparent magnitude of the moon. So out here, it would be a great idea to build a telescope at first, I must say. I am campaigning for it. Basically, as society progresses, whatever the edge of society happens to be is the best place to put a telescope. So right now, it would be great to go put a telescope on the far side of the moon because all of the light pollution, all of the radio from Earth, all that sort of mess, all that artificial contaminants will not interfere with the data if you have a telescope on the moon. And even less so out here in the Kuiper Belt, in the Detached Objects zone. So yes, that's one thing you could do. Also, these objects might act as like I don't know, foundations for interstellar travel. You might have interstellar trips start in the Detached Objects zone just because you could build interstellar ships out of large icy bodies. You could just hollow out an icy body. Because basically the process by which you create an O'Neill cylinder is also the process by which you can create an interstellar ship. Because an O'Neill cylinder really is just an interstellar ship that happens to be following an orbit around the sun. Because there's nothing stopping you from just accelerating away and going on an interstellar voyage to Proxima Centauri. So that's what you might see out here.
Yeah.
Finally,
the Oort Cloud, the Valentine of the Kuiper Belt. Oh, yep. The Oort Cloud. Now, there's a legend about the Oort Cloud. The Oort Cloud ghost. It was said that he was a lone traveler, the first man and or woman to ever travel into the Oort Cloud. He's both. And she went into the Oort Cloud with one mission, was to find the sacred Oort treasure. The fabled Oort treasure that could reverse entropy.
Ooh.
But they were lost in the Oort Cloud, and it is said that their ghost wanders the cloud, ever searching for its lost treasure.
Wow.
I needed my guitar to do some, like, exposition music in the back.
Yeah, exactly. But yeah, so the Oort Cloud starts at about 1,000 or 2,000 AU away from the sun and goes out as far as about 100,000 or 200,000 AU, which is halfway to the nearest star. This is a crazy, crazy place. We don't even know if it's real. So the Oort Cloud itself is an urban legend. It's just theorized. We haven't observed any Oort Cloud objects yet that are currently residing in the Oort Cloud. Although theory states that like a lot of the comets that we see are Oort Cloud objects that flew a little too close to the sun, but we do not know. There could be other explanations, but it's a theory. It's just a theory right now. But I think it's real. It's probably real. It's like very likely real. It's just we haven't directly observed it. It's like as real as black holes were real in 2018 before the picture.
Yeah.
You know what I mean? Like it's pretty much certain. So yeah. So let's begin. We've got the Hills Cloud. So the Hills Cloud is the inner Oort Cloud, named after some guy called Hills, and it's just an interesting zone. So this is where we like transition from a disk to a spherical cloud, because most of the objects in the solar system are all roughly on the same disk. But as you get into the Kuiper Belt and the scattered disk, the detached objects, they just increasingly have increasingly weird eccentric and inclined orbits. So the Hills Cloud is where you reach peak inclination. Everything is just traveling in every which way, just random orbits, like no rhyme or reason to it. It's a cloud, right? Think of a cloud of gas particles. Think of just gas particles randomly going around. That is what you have out here. That is what you have in the Hills Cloud. So it's just ice and stuff out here, just ice. It's not very dense. It's probably the least dense of all of these. If it's, we don't know as much about the density, but it's probably not very dense. But again, the objects that are there, people will likely go to them and inhabit them. So next we've got Galactic Tide, which is something that begins to take effect out here. And so Galactic Tide is just interesting, just a weird thing to think about. But it's basically that the Hills Cloud is so large that the part of the Hills Cloud that is closer to the center of the galaxy is pulled on more intensely than the part that is farther from the center of the galaxy. And the part that is closer to the center of the galaxy is going to be orbiting the center of the galaxy faster, whereas the part that is out is going to be orbiting slower. So you've got this tidal force that messes with the Oort Cloud. And the farther we get from the sun, so the deeper into the Oort Cloud we go, the more that Galactic Tide takes effect. And eventually, Galactic Tide just completely overrides the sun's power, and the sun is no longer even gravitationally holding on to it. So let's look at outer Oort Cloud. So the outer Oort Cloud is, like 20,000 to 100,000-ish. It's just the outer range. It's theorized, that comets come from here. It's theorized also that the Oort Cloud was created when it's just all of the material that used to be in the center of the solar system was either pushed out by solar wind or flung out due to gravitational interactions with the gas giants. But everything is just pushed out to the outer Oort Cloud, banished from the solar system, left to rot in the dark zone of the solar system.
The dead zone.
Yeah, exactly, the dead zone. But yeah, so that's the Oort Cloud. Really, it's just similar. It's that the main things for habitation here is that there's going to be icy bodies, and we are going to have to find a way to use nuclear fusion for energy, because there is just no viable way of getting sunlight out here. It would be very difficult. It would be a massive endeavor. So next we've got interstellar rest stops, and this is just sort of I like this picture. Just interesting.
Yeah, I'm telling you, this is what it's gonna be. They're like, it's gonna be the husband and the wife driving, and the wife's like, "You're lost. You gotta pull over." And you know, the guy's like, I don't wanna. I say this because that's how I don't wanna ask for directions. And he's like, I don't wanna pull over. I know where I'm going. I have natural. That's the North Star. I know where I'm going. And he's like, no, there's a rest stop right. And he pulls in, and he's like, hi, where's Alpha Centauri? And they're like, in that general direction. He's like, thank you. And the wife's like, could you give me some gum? He's like,
yep.
And he goes and he gets you some gum, and then he gets himself a Slurpee anyways. She's like, aren't you glad you pulled in? And he's like, stop talking to me. And they just drive in silence for the next 25,000 years.
Yes. Yeah, so out here the sun is 1/1,000,000th to 1/10,000,000,000th as bright, which is, negative 11.7 to negative 1.7 on the apparent magnitude scale, and the star Sirius in the night sky is negative 1.4. So out here, the sun is just another star. Isn't that just crazy? Imagine, the most chilling feeling will be when someone looks up into the night sky on some alien world, and they can't tell which one is the sun. They're like, I forget. Can't tell. It's not distinguishable. And what'll be even more chilling is when it is just too dim to see. So, yeah. But interstellar rest stops is just interesting. For interstellar travel between established systems, so say that there are people living on Alpha Centauri and there are people living in the solar system, and they just establish trade routes, it's possible to create, and we'll talk about this more in future episodes because we're going to talk about interstellar travel, but it's possible to create interstellar highways. It's sort of like in Hitchhiker's Guide to the Galaxy. That's why they destroyed the Earth.
Yeah.
But I don't think you would need to destroy planets for the sake of this interstellar highway. Just push them out of the way, really. Mm-hmm. I don't know why they didn't think about that, but anyway. But yeah, so the way that you would do that is by just having a giant column of light. Just a giant column of light that is going to Alpha Centauri. You would have one column going towards Alpha Centauri and one column coming back to the solar system. And the reason you would do that is that then ships can use solar sails or just, light sails, laser sails. They can unfurl their massive sails and just ride the waves, essentially. The waves of light that are streaming out from the inner solar system. So this would be like Dyson sphere. You would need a lot of energy to support this. But if people are traveling back and forth routinely to the Alpha Centauri system, then it'll be worth the energy. But the thing is, every laser that we have diverges over time. It disperses. No matter how tight the beam is, the beam always just gets unwound. So you're going to probably need a ton of these rest stop stations that'll recollect the light and then spit it back out in a more concentrated manner. They're going to require a lot of material. They're going to need hydrogen and stuff to fuel nuclear reactors, because I think it takes a lot of energy to refocus light like that. Just because if you could refocus light without expending energy, then that is reversing entropy, which is a big no-no. So that's going to need to happen. So there's probably going to be stops along the way to Alpha Centauri. I like to imagine you've got a little rest stop like this one, and it's halfway to Alpha Centauri. And it's just people are like, oh, should we stop? Take a break? But realistically, there probably wouldn't be much between the stars, because there's no point, because you're just trying to get to the star. It's also, it would be very inconvenient because you're traveling at close to the speed of light. It's unlikely that you're going to stop. But for the sort of sci-fi space opera thing that's more sci fantasy, it's not quite hard sci-fi, I guess, just more soft science fiction. This is the kind of fun stuff that you want to add in, although it's not that practical. But there will definitely need to be rest stops. It's just they're not going to be like rest stops on a highway. They are stations to maintain the highway. It's they're not for amenities. Although they probably would render emergency services if, say, your ship like some interstellar grain of sand like punctures your like water tank and you just have no water anymore, because when you're going at such fast speeds, like a grain of sand or just dust will really wreck your day. But people might be like, oh no, we're running out of water, so they might have to stop for emergencies at one of the rest stops where they would render emergency services. But it wouldn't be a normal part of your trip, because that would just slow you down, because you'd have to decelerate and then accelerate again. So it's like, yeah. But it's also interesting, and another thing to think about on the interstellar highways are like, sort of like space hippies again, is you could have like stellar highway like surfers, because it's like windsurfing but with a solar sail, and it's also kind of like stowing away, like when people jump on a train. You know how they do that, like in like stories that take place in like the early 1900s. Usually you've got like, oh, they run and then they hop on the train, and then sometimes the like police or whatever are like, oh, get off the train, because you're basically just hitching a free ride. You could get like windsurfing space hippies that are hitching a ride on like the edge of the Stellar Highway, like the laser highway thing. Could you imagine that? And so you've got some hippie guy around the fire again, and they're like, how did you afford the travel expense to get from Alpha Centauri to the solar system? And he's like, man, I just solar sailed, I just laser surfed my way there. And everyone's like, wow, so cool. How does he do that?
Space pirates.
Yeah.
We need space pirates.
Space
That's what
pirates,
we need.
Yes.
We need it
space pirates.
now. We needed it yesterday. We need it now.
I could talk about space pirates for like an hour. There's like so many intricacies with space piracy. I won't though. I won't talk.
Yeah, but I mean, like, it'd be fantastic just to be on a group, just a ship of lads and ladettes, with just. Everyone has their own job, like on a pirate ship, and y'all are just some celestial scallywags, celestial swashbucklers. Yeah, all that. Just, and you guys just go all the way across the solar system, just in search of some loot.
Haul.
The big haul, the Oort treasure.
The Oort treasure,
if you may.
The Oort.
And the guy at the
it's a pirate legend.
Yeah, the guy who's telling the story is telling the story of old Captain Jack, who sailed the high solar tides of the Oort Cloud in search of the Oort treasure, and at the end of the movie he reveals himself to be old Captain Jack.
Amazing.
Yeah. Thank you. It really does.
But yes, that's interstellar rest stop. So next, we've got tidal truncation radius. So this is about the stellar tide, or the galactic tide, as I was saying before. And this radius is somewhere between 100...
It is capturing my cursor. Sorry, I forgot to...
Yeah. It's somewhere between 100,000 and 200,000 astronomical units from the sun, which is, for reference, somewhere between 1.5 and 3 light years. So that's very distant. Halfway to the next star, essentially. But past whatever this distance may be, outside of the tidal truncation radius, any object is not bound to the sun. It is not orbiting the sun. It is orbiting the galaxy. It is an independent object. It is some small space rock, or even rogue planets, because rogue planets are a thing. Some object that has been cast out of its home solar system and is now forced to wander the plains of the galaxy for eternity, searching for light. So, yeah, you don't want to end up out there. You don't want to be banished past there's no coming back. There's no coming back past the tidal truncation radius, without fuel, that is. If you have fuel, then you can just, rocket your way back in. But stuff outside the tidal truncation radius will just leave. So if people start settling space rocks out here, after like a few 100,000 years, they're gonna have to be like, oh, wait a minute, we're going to have to do a course correction and get back into the solar system. Otherwise, we're just going to drift away. But maybe that's the intention, is to drift away, because in their intragalactic drifting, their interstellar drifting, they might pass near another star, another uninhabited star. And if they do, then they can maybe claim it for themselves. Who knows? That's a method of interstellar travel. It's like no destination interstellar travel, you know? That's just an interesting thing. Like right now we think of like, oh, we want to go to Alpha Centauri specifically. But some people might set up just a self-sufficient asteroid colony that has enough, you know, water to last itself like a few million years. And so then they'll just let themselves drift out through the galaxy. And whenever they happen upon a star that they like, they'll just say, hey, why don't we stop here? And then they'll colonize a new solar system. And some people might decide to stay on board, you know, like half the colony could be like, oh, let's stop here. And half of the colony would be like, no, we don't want to stop here. And so they would just go their separate ways. So some people would stay and colonize the solar system. Others would drift to the next solar system. So it's very interesting.
Space pirates.
So space pirates.
Space pirate hippies.
Space pirates. Space pirate hippies. Space pirate hippies. Bottom text.
Bottom text.
All right. So now we go to interstellar space. I saw a meme recently where someone said middle text. I was like, oh.
It's evolved. That's what's on Planet 9. Is middle text.
Is on Planet 9.
Oh my lord.
Yeah. But now we get into interstellar space. We get to other star systems. So this is the fullest extent of the solar system. We have covered the whole solar system, guys.
Yeah, we did it. We got to the end.
Woohoo! End of the solar system.
You've
party.
won the game.
You've won the game. Now you're on free play mode. So now you can go to other solar systems and do other fun things. So that's what we'll be talking about next time. Let's see, what's next on the agenda? I think next on the agenda is...
just looking at it.
Oh, it is interstellar travel, yes.
Right. So we've given you the roadmap. Now, how do you get around?
Yeah.
What is your method of transportation?
Exactly. How are you going to get there? What's it going to be like? You know, when you get there, how might, you know, people on the how might people in the solar system maintain communication with people on Alpha Centauri? How might they maintain a government? That's what we're going to be talking about. Interstellar travel, interstellar empires. So with that being said, final thoughts.
My final thought is we need to make Space Pirate Hippies a real movie.
Space Pirate Hippies. That should be the title. Like
it should be, it's intentionally like that. Yeah.
Yep.
Or we can make it intentionally super long. Space Pirate Hippie Ninjas from the outer realms of the universe.
No, wait. Space Pirate Hippies and the quest to Planet 9. Like something like that.
Yeah.
And the journey to Planet 9.
And it stars Jack Black.
Yes.
And Mike Myers. And Seth Rogen. And I want and Morgan Freeman is there, but you don't really see him, but he's there. He's Captain Jack. He's like, and there I was, and he's just talking about how he's out there, like in the outer realms, looking for Planet 9.
Oh yeah.
Old Captain Jack couldn't find it.
Yeah.
He was looking for treasure.
So, the next time you just brush over the Kuiper Belt or the Oort Cloud, you must take note of your folly. Because look at what a rich culture you can have out here in the Kuiper Belt. Look at all the fun times you can have. Look at all the interesting things that can occur with the space pirate hippies and all that. So, yeah.
I'll make the movie poster, and then you can throw it on the social media.
I'll put it on the social media right after. I want to tweet. Eris is over party.
Eris is over party. Let's go, guys. It's over.
So yeah, but that's it. So thank you guys all for watching. This was a fun episode of the Gravity Max live stream. I'm a personal fan. I love the Kuiper Belt. Kuiper Belt's one of my.
I thought you were about to say you're a personal fan of the Gravity Max live stream.
Yeah, I'm a personal fan of that too. But I really like the Kuiper Belt. I think it's an interesting place. I like Pluto, despite it's really funny. When I say, like, again, when I say Pluto's not a planet, people are like, oh, you hate Pluto. And I'm like, no, I think Pluto is one of the coolest non-planets there is. So